Low levels of this nutrient can wreck your thyroid, reduce your ability to cope with stress, and destroy your memory. Stay tuned for Dr. Osborne's Zone as we discuss this key amino acid. You unlock this door with the key of compassion. Beyond it is another world, a world of science, a world of common sense, a world of sanity. You're moving into a land of both empathy and ethics, of nutritional knowledge and empowerment. You've just crossed over into Dr. Osborne's Zone. Welcome to Dr. Osborne's Zone. Today, we're going to be diving into the amino acid tyrosine. So, what exactly is tyrosine? Tyrosine is an amino acid. It is non-essential, meaning that your body can produce it from other amino acids, but there's a conditional essentiality to tyrosine that we'll get into. So it's a non-essential amino acid first discovered in 1846 by the German chemist Justus von Liebig. The name tyrosine originates from the Greek word tyros, meaning cheese, as it was originally isolated from the protein casein found in cheese. Now, from isolation to functionality, what are the main key roles that tyrosine plays in the body? Number one, it's necessary to make thyroid hormones. Number two, it's necessary to produce dopamine, the pleasure hormone or the pleasure neurotransmitter. You need it to make adrenaline and noradrenaline. These are your stress hormones, sometimes referred to as epinephrine and norepinephrine. You also need tyrosine to make melatonin, and it's very key for a group of signaling molecules in your body called kinases, tyrosine kinases. Very, very important group of molecules related to cancer and cell growth and many, many other functions. So tyrosine is a pretty important amino acid overall. Now, if we look at these chemical pathways visually, it'll hopefully make better sense for you. But here you can see in this diagram, tyrosine right here in the middle. Tyrosine is a non-essential amino acid predominantly because you can make tyrosine from this amino acid right here, this one called phenylalanine. Also found, both of these found in protein. That's where you eat protein. So predominantly meat, certain nuts and seeds and other things. Now, in order to make tyrosine, the body has to have adequate vitamin B3, iron, folate, and a substrate of folate called BH4. So in essence, to turn phenylalanine into tyrosine, we need these B vitamins and we need iron. Once we get to tyrosine, it's used to make the following chemicals. One is L-dopa-levodopa. Now, you may have heard of this term before as it relates to Parkinson's disease. This is a common medication that's given in Parkinson's disease. They give L-dopa. Why? Because in these patients, their ability to produce dopamine is diminished or damaged. Those cells in the brain that make dopamine become damaged, and so in Parkinson's disease, people start to develop tremors and nervous system dysfunction. So tyrosine is the precursor to making dopamine, and its precursor L-dopa. So again, this is a medication that's sometimes used in patients with Parkinson's disease, but you can't make it internally without tyrosine. Now, in order to convert tyrosine into L-dopa, again, you can see up here where it says cofactors. Cofactors just means nutrients that run the biochemistry of this conversion. So you need vitamin B3, iron, folate, vitamin D, and omega-3. So very, very important. You know, many of you are thinking, do I need tyrosine? Do I need to supplement with tyrosine? If you're going to think about doing that, you might also want to ask or think about, are my levels of these nutrients also low, right? And then from L-dopa, we can make dopamine, and dopamine requires vitamin B6, that's PLP, as well as iron. And you remember dopamine's function predominantly is in our reward centers of our brain. So dopamine makes us feel happy and fulfilled. Dopamine also regulates motor, muscle control. This is why people with Parkinson's and other dopaminergic types of diseases develop tremors. From dopamine, we can make norepinephrine and epinephrine, or noradrenaline and adrenaline. And to do that also requires cofactors, vitamin C and copper, to make norepinephrine. And for folate, or for norepinephrine to epinephrine, requires folate, something called SAMe, which is abbreviation for S-adenosyl methionine. It's a type of amino acid that is critical for that conversion. And then as well, you need magnesium. So why are these, dopamine is important because of its reward motor control. Why are these two important? Norepinephrine and epinephrine both play a role in our stress response. And so how do you cope or adapt to stress? Well, your body produces these hormones that allows the mechanistic aspects of your body to upregulate blood pressure and blood flow so that you can adapt or deal with the stress at hand. A lot of people develop, especially with chronic inflammation, develop an inability to cope or adapt to stress. And this is one of the reasons why. They've burned through these nutrients, and now they're left with an inability to actually make stress hormones effectively, so they don't deal with stress. Now, also, beyond the synthesis of stress hormones and dopamine, tyrosine is also essential for producing skin pigments. So you can see up here, tyrosine as a chemical goes through several different types of reactions to make the pigment melanin. So in this case, eumelanin, and over here on the other side here, pheomelanin. These are just different types of melanin. Remember, melanin is what makes our hair color. It's also what gives our skin color. So the pigment of your hair and your skin is dependent upon tyrosine. There's some research, if you watch my show on graying of the hair, there's some research that shows that tyrosine, for some people with premature graying, can actually be very helpful in hair coloration. Now, we also know that tyrosine plays a role in thyroid hormone production. So as you see here in this diagram, over here in the blue, you've got tyrosine, and then chemically converting into T3. That's triiodothyronine here, and I've underlined it. And then from T3, we make T4, thyroxine. So if any of you have hypothyroid illness, hypothyroid, it's interesting how many doctors ever measure tyrosine to determine whether or not it's a cause or contributing factor in low thyroid. I've not seen it yet. I do it all the time, but I haven't seen a single patient in 24 years of practice come to me from their endocrinologist where they've had hypothyroid, where tyrosine was ever measured as a means to try to identify why their thyroid wasn't working properly. But the T in T4 and the T in T3, so when we look at thyroid hormone, T4, which is thyroxine, and you can take the drug thyroxine as there are a number of different preparations like Synthroid or levothyroxine. But the T in that T4 is tyrosine. The 4 in that T4 is iodine. So in essence, thyroid hormone is tyrosine, the amino acid, plus 4 molecules of iodine. That's what it is. And T3, much the same. T3, the T is tyrosine, and the 3 is iodine. And to get from T4 to T3, we have to take away an iodine, and that conversion requires selenium, which is why so many of you probably have read about selenium's role in thyroid hormone, because it activates thyroid hormone. T3 is active thyroid hormone. It's the one that does most of the metabolic functioning and most of the metabolic work. So again, you can't make thyroid hormone without tyrosine. So very, very important key amino acid that your body isn't going to do well without. So now let's answer the question, who might benefit from taking tyrosine or eating more foods with tyrosine? Well, what I'm going to show you here are the supplementation in the human trials and the human research studies on benefits of tyrosine. So the first category are people that have improvements in cognitive function, cognitive performance. Their brains work better. So you can see here, tyrosine supplementation has been shown to enhance cognitive flexibility and working memory, particularly when people are under stress. Remember what I said earlier about tyrosine and its functions? I said that you can't make epinephrine and norepinephrine without tyrosine. These are your stress hormones. So under stress, when people take extra tyrosine, when they're under stress, their memory improves. The same thing is during sleep deprivation. So where a lot of the research on tyrosine has come from is in the military. When they put these soldiers under intense stress, they make them stay up longer. They give them tyrosine to see if it improves their performance, and it does. We also have research on stress resiliency. Evidence suggests that tyrosine may help mitigate the adverse effects of acute stress by sustaining neurotransmitter levels. Of course, the neurotransmitters we're referring to, dopamine, epinephrine, and norepinephrine, thereby improving performance in challenging environments. We also have mood regulation. Some research indicates a potential role in alleviating symptoms of depression and anxiety. Remember what we said about dopamine. Dopamine is the hormone that can bring us happiness and bring us satisfaction and a sense of peace. Exercise performance. We got preliminary studies have linked tyrosine supplementation to improved endurance and reduced fatigue during prolonged physical activity. So let's look at some of these research studies. This first one here this is just a summary published in Pharmacology, Biochemistry, and Behavior. So you see here the highlights. Tyrosine is the dietary precursor to dopamine and norepinephrine. We reviewed 15 studies on the effects of tyrosine on human behavior or cognition. What they found, cognitive improvements can be observed after a single tyrosine load, meaning a strong dose of tyrosine. Number two, behavioral changes may only appear after repeated tyrosine supplementation. So for behavioral improvements, prolonged use was necessary. And then their takeaway, future studies should focus on long-term effects of tyrosine. Here's another human study. You see here 10 men, 10 women subjects underwent batteries 1 hour after ingesting 150 milligrams per kilogram of L-tyrosine versus a placebo. So they kind of give you a rough estimation of that dose. Depending on the weight of the human, that's somewhere between 7 and 12 grams of tyrosine. And in this case, what we're really referring to is the L version, L-tyrosine. That's the one that humans take. That's why you see the L here. So L-tyrosine. Administration of tyrosine significantly enhanced accuracy and decreased frequency of list retrieval on the working memory task during the multiple task battery compared with placebo. In other words, they performed better on the tests they were given. You see here, tyrosine may sustain working memory when competing requirements to perform other tasks. So again, when you overload somebody with multiple things to do, tyrosine helps to sustain working memory. We also see and that supplemental tyrosine may be appropriate for maintaining performance when mild to severe decrements are anticipated. So takeaway there is, if you've got a big project that you've got due at work, or you've got something major coming up at work, a strong bolus of tyrosine could potentially be helpful in helping you maintain your focus and concentration. Here we've got another study on tyrosine on cognitive and psychomotor performance. Is 15 subjects. They gave 300 milligrams per kilogram of body weight, so even more than 150. So this is like 15 to 25 grams of tyrosine. And then they subjected these people to extreme cold. And then the outcome, the data support previous findings that dietary tyrosine supplementation is effective for mitigating cold-induced cognitive performance. such as working memory, even with reduced core temperature, and extends these findings to include the psychomotor task for marksmanship. So they had them shooting their guns. Again, military studies where tyrosine helped with performance. Then we have this one, tyrosine. 12 patients with clinical signs of dopamine-dependent depression. So these patients were depressed. It was confirmed that their depression or that they had dopamine deficiencies. And so these people were treated with oral tyrosine. They used in this study 3,200 milligrams a day, so a lot lower of a dose than what we've seen in some of these other studies. On the very first day of treatment, a return to mood as judged by clinical impression scores was observed. Sleep recordings performed on nights following days 1, 2, 7, and 8 of treatment showed an immediate improvement of those sleep parameters, differentiating them more clearly dopamine deficiency depression from other types of depression. More than 50 patients have now been treated successfully for periods ranging from a few months to almost 2 years. So again, the specific here is that this treatment works if you have a dopamine deficiency. If you do not have a dopamine deficiency, because there are multiple causes of depression, so maybe you're depressed, but if you don't have a dopamine deficiency, using high doses of tyrosine may not be very helpful for you. But if you do, worth asking and talking to your doctor about it, because the downside to taking strong doses of tyrosine is pretty low key. The downside to some of these antidepressant medications is pretty intense. So anytime we have a natural, we would say nutraceutical way to deal with something with the lower risk of side effects or lower risk of untoward long-term effects, obviously that's a better option. Here in this review, this was a systematic review published in the journal Nutrients in 2020 on military personnel. We suggest that tyrosine or caffeine could be used in healthy adults in a military context to enhance cognitive performance when personnel are sleep deprived. So these individuals being deprived of sleep, using tyrosine to improve functionality. Here's another study in humans. This one, 8 healthy male volunteers given 150 milligrams per kilogram, again, somewhere between 7 and 12 grams of tyrosine if you're taking average human weight, in a double-blind manner 1 hour before cycling to exhaustion. So they put these people on a cycle. The results show that acute tyrosine supplementation is associated with increased endurance capacity in the heat in moderately trained subjects. The results also suggest for the first time that the availability of tyrosine, a nutritional dopamine precursor, can influence the ability to subjectively tolerate prolonged, submaximal, constant load exercise in the heat. So these healthy male volunteers were being exercised at a reasonable rate in hot weather, and taking tyrosine load before the exercise improved their ability to sustain that activity. And then you have this one here, effects of tyrosine supplementation on clinical and healthy populations under stress or cognitive demands. This was a review study. You see the summary down here. Tyrosine does seem to effectively enhance cognitive performance, particularly in short-term, stressful and or cognitively demanding situations. We conclude that tyrosine is an effective enhancer of cognition, but only when neurotransmitter function is intact and dopamine and or norepinephrine is temporarily depleted. So again, what they found in their review of multiple human studies is if you had low dopamine and low norepinephrine, taking tyrosine was a good thing that offered benefit. Now, I've seen tyrosine in other ways clinically. These are some of the human trials, but I'm going to give you some of the anecdote I've seen clinically with tyrosine. And so one of those has to do with tyrosine being used for pain. And why is that? We look at some of the newer research studies that are coming out, nothing done in humans, but again, kind of corroborating my experience clinically. So you see here, dopamine's crucial role in priming chronic pain. A newly published study found that dopamine is integral to how pain becomes chronic. This could lead to further insights to help treat fibromyalgia and other chronic pain conditions. Now, on that note, if you look here, fibromyalgia patients show an abnormal dopamine response to pain. Again, dopamine is implicated in both pain and modulation and affective processing. These findings provide the first direct evidence that fibromyalgia patients have an abnormal dopamine response to pain. The disrupted dopaminergic reactivity in fibromyalgia patients could be a critical factor underlying the widespread pain and discomfort in fibromyalgia, and suggests that the therapeutic effects of dopaminergic treatments for this intractable disorder should be explored. Well, what does that mean? That means that dopamine helps regulate pain. Pain is very complex. It's not just hammer to your toe and it hurts, but there are multiple nerve receptors. There's inflammatory chemicals that are released. There are different types of nerves that regulate pain and send pain signals. It's super complex, and sometimes it's complex because just the people are different. But what they're saying in this is that enhancing dopamine may actually enhance people's pain response. And when I say enhance the response, reduce their pain. So what is a dopaminergic treatment option? Well, in the case of nutrition, it's tyrosine. What I showed you before here, right, we have tyrosine being a direct precursor to perform or to produce dopamine. And so this is actually interesting too. I want to point a few other things out since we're talking about pain here, but we have tyrosine converting to dopamine, but look at the nutrients, going back to the cofactors here. These two are two I want you to pay close attention to, the vitamin D and the omega-3, because there have been a number of human studies showing that vitamin D and omega-3 supplementation reduce pain. There's some studies that show that omega-3 at higher doses reduces pain more effectively than non-steroidal anti-inflammatory drugs. I use it on a regular basis in my practice, but is this possibly one of the reasons why? Omega-3 has more than one function, but one of its functions is in this tyrosine to dopamine formation. So omega-3 is important for that conversion. Omega-3 also has anti-inflammatory properties. Same thing with vitamin D. It has multiple functions, but one of its functions is in this conversion. So these two can reduce pain when you give them. Is the reason they reduce pain possibly having to do with improvement in dopamine? Also, iron is another one. So iron deficiency can cause tremendous pain. Iron deficiency depletes oxygen into the muscles and into the other tissues, leading to enhanced pain, and iron also playing a role in the production of dopamine. So I say keep that in mind, because many of you are in pain and you're thinking, I'm going to take some tyrosine. But if you're going to do that, I always recommend you check out the cofactors that help tyrosine do what it's supposed to do, and you probably will have a greater degree of success. Now here's another paper on dopamine as a precursor. And so you see decreased dopaminergic neurotransmission in 22 healthy human subjects using acute phenylalanine and tyrosine depletion. So they depleted these patients of tyrosine and phenylalanine so that they couldn't get to dopamine. And here's what they found. Okay, our findings of an influence of dopaminergic neurotransmission on affective but not sensory aspects of phasic pain suggests that analgesic effects of dopamine might be mediated by indirect effects on pain affect rather than by direct effects on ascending nociceptive signals. Let's make English of that. Basically, dopamine regulates pain indirectly, not through the nerve itself, but indirectly with some other mechanism. That's at least the conclusion of these authors. These findings contribute to our understanding of the complex relationship between dopamine and pain perception. This is, again, dopamine is more of a pain perception versus an actual nerve inflammatory cascade. which may play a role in various clinical pain states. So improving a person's dopamine outcomes. Look, we know people that are depressed. We know people that have psychiatric inflammation. We know people that have poor job satisfaction. These people are all more prone to pain. And one of the theories behind their chronicity toward greater pain has to do with dopamine depletion. Remember, when we do things we love, when we live the life that's right for us, we naturally make more dopamine and our dopamine pools stay higher, and that regulation of happiness has an alteration on the way we perceive pain. So dopamine, very, very important in that regard. And I've seen this be true in my practice for years, helping people with chronic neuromusculoskeletal pain. Now here's a tie-in to celiac disease and gluten. So those of you who are gluten sensitive, research on people with celiac disease, several studies have revealed abnormalities in monoamine metabolism in patients with active celiac disease. So what is a monoamine? This is dopamine, adrenaline, and noradrenaline. That's what monoamines are. So those neurochemicals of stress and happiness. Malabsorption in active celiac disease is linked to brain function and depression via reduced uptake of amino acids. In this case, what are we talking about? Tyrosine. And this study actually also alludes to the amino acid tryptophan, which we're not focusing on today. But for those of you who just want a tidbit, tryptophan is a precursor to serotonin. Serotonin being the neurochemical that helps regulate gut motility and regulates mood as well. It's one that's oftentimes targeted in pharmacy for antidepressant effects. But at any rate, they found significantly lower plasma tryptophan and lower plasma tyrosine concentrations compared to controls in patients with celiac disease at 1-year follow-up. In other words, celiac disease patients had lower tyrosine. We know that many celiac disease patients struggle with depression and symptoms of neural inflammation and psychiatric disease at a much higher rate than the general population, in part because gluten damages and inflames the brain, but also in part because of the malnutrition, the malabsorption. And one of the things that's malabsorbed with the celiac gut or the gluten-damaged gut is protein. And if we look at protein, is made out of what? It's made out of amino acids. And tyrosine is one of those amino acids. So when we talk about protein deficiency, it's kind of an all-inclusive conversation to include all of the amino acids together, like tyrosine, like tryptophan, phenylalanine, and many of the others. So again, celiac disease patients more prone, more common that they have tyrosine deficiencies, and that might play a role in some of their depression. I want to talk about dopamine a little bit more as it relates to the gut. Because we can make dopamine from tyrosine. Go back to that diagram that I showed you earlier. And that's a human pathway of production. So human cells can make dopamine from tyrosine. And a lot of that happens in the gut. As a matter of fact, you can see here, based on this study, more than 50% of dopamine in the human body is synthesized in the gut. Now, what we're not clear about is how much of that dopamine is made by us, made by our cells, and how much of that dopamine is actually made by bacteria. The microbiome, the microbes that live in your gut, many of the different species produce neurochemicals like dopamine on demand. So when they sense that the body needs it, they can actually uptick and start making dopamine. Now, one of the things that we've seen going on, let's tie this in and make it make sense. We've seen going on since the 90s is the massive use of the chemicals to enhance the growing of our crops. And the main chemical I'm referring to here is glyphosate. And one of the side effects of glyphosate is it blocks in plants and in bacteria. So in the plant and bacteria kingdom, so bacteria and plants also make dopamine or have tyrosine and make dopamine, among other things. And so what happens is this chemical glyphosate blocks the ability of bacteria and other plants to go through this biochemical pathway called the shikimate pathway, which is the pathway whereby we make we make these chemicals like tyrosine to dopamine, and so and also phenylalanine is made by this pathway. So you can see, since dopamine is synthesized from tyrosine and its precursor phenylalanine, both tyrosine and phenylalanine depletion by glyphosate in both plants and microbes would be expected to reduce their bioavailability in the diet. It has been demonstrated that dietary reductions of both phenylalanine and tyrosine induce reduced dopamine concentrations in the brain. So we know that when phenylalanine and tyrosine are limited in the human diet, or limited availability for humans, we have a reduction of dopamine in the brain. Impaired dopaminergic signaling in the substantia nigra is a key feature of Parkinson's disease. So substantia nigra is just a region of the brain. Parkinson's disease is what we talked about earlier. The bottom line is that glyphosate was actually patented, and part of its mechanism of action is to block this pathway, this shikimate pathway, whereby in bacteria and plants cannot produce tyrosine or phenylalanine. And so when we rely on some of our bacteria within our microbiome to produce these things, but we're eating foods that are doused in glyphosate, is it possible that glyphosate is impacting our own bacterial bioproduction of these key amino acids? On the second point, is it possible that this glyphosate is depleting plants of these amino acids? And so if we're relying on plants, especially somebody maybe on a plant-based diet, to get some of our amino acids, are these key amino acids being blocked because they're not organic, because they're loaded up with glyphosate as well? And that's the big question mark. What I have seen clinically is yes. And this is one of the reasons why when we see somebody go from eating a kind of a conventional diet to eating a diet that's rich in organic, real food, right? Getting the processed pesticides and herbicides out of the diet, but eating organic, real food, a lot of times, even without supplementation, these people have dramatic turnarounds and many types of symptoms, but a lot of them, like pain and inflammation, and even in many cases autoimmune, antibodies drop, additional other kinds of symptoms can go away. Brain fog, energy improves, gastrointestinal motility improves, bowel function improves, digestion improves, skin inflammation can improve. So just by making this switch, right, if you're trying to say, okay, maybe I don't want to take a bunch of supplements, but what can I do? Well, eat organic, real food, get the glyphosate out. The glyphosate is limiting our ability to get to phenylalanine and tyrosine, not only through the plant foods that we eat, but also through our own internal bacterial production. Remember, 50% of dopamine in the body is synthesized by the gut, and that includes production by the gut microbiota. Okay, so let's bring in another topic here that can affect the conversion of phenylalanine to tyrosine. So remember, phenylalanine is an essential amino acid that our body can take from our food and convert into tyrosine. So what I want to show you here is research on the mycotoxin, something called ochratoxin A, which is a substrate for phenylalanine hydroxylase. What does that mean? That means that this ochratoxin A, OTA, is a mycotoxin. It's a mycotoxin that can contaminate your home. It's made from different species of mold, Aspergillus and Penicillium. Molds can make ochratoxin A. Again, it's a mycotoxin, and one of the things that this mycotoxin does is it inhibits the enzyme this hydroxylation enzyme that converts phenylalanine into tyrosine. And this is, when we look at many people who are subjected to mold toxins, ochratoxin A, these people can be depressed. They can develop more pain, chronic pain. They typically have memory issues. They typically have cognitive decline. So think about all the things we just said tyrosine has been shown in human trials to benefit. It benefits memory. It enhances physical performance. It enhances accommodation to stress. It helps people maintain functionality when they're under stress because of the fact that tyrosine helps us make stress hormones. Well, this mold toxin blocks the production of tyrosine by the amino acid phenylalanine. And in so doing, we see a lot of the mold symptoms matching deficiency of what we would see with somebody with low tyrosine. And so I want you to be clear about that too, because many of you are in mold and you may have these symptoms and you can take tyrosine and you might get some bypassing of this chemical inhibition of ochratoxin A, but it's not going to solve a mold problem. So my point is, if you struggle with a lot of the symptoms of mold toxicity, which are very similar to the symptoms of tyrosine deficiency, ask your doctor to check you for ochratoxin A and just get it ruled out. Why? I know a lot of you may be rolling your eyes. I can hear the eye rolls. If you haven't been in mold and you don't understand mold, generally you don't want to think about it. But let me just give you one statistic that should alarm the hell out of you. And that is, this is according to the EPA, 50% of buildings in the U.S., this is U.S. statistics, are water damaged. What does that mean? That means they have the potential for mold to be growing in them. The most common molds that grow in water damaged buildings: Aspergillus molds, Penicillium molds, Stachybotrys, which is black mold. But 50%, this is not a small number. And I know some of you may even be thinking, I'm in new construction, I don't have to worry about that. That mold stuff only happens to houses that are old. What we see clinically is that new construction is worse, because the newer construction in today's world, they cut corners and they use unskilled labor to do the work. And so when you have a bunch of cheap labor, unskilled workers building your house, cutting corners, they make mistakes. And a lot of these mistakes lead to water penetration into the house. And I'm not talking about necessarily a broken pipe or a leaky roof. Most of us understand that that level of water merits a major cleanup. I'm just talking about water vapor, because you don't need running water to grow mold. You just need bad construction that leads to increased water vapor. So one of the easiest ways to this isn't the only way, but one of the easier ways to kind of check your house is to measure the humidity in your house. You can buy a hygrometer on Amazon or for $8, $9, something like that. Or you can look at your thermostat. A lot of thermostats have built in a humidity measurement reading. But if that relative humidity in your house is chronically above 55%, you've got enough water vapor to grow mold. And so I would look at that today if you're having these symptoms of brain fog, fatigue, chronic pain, fibromyalgic-like symptoms. If you've been diagnosed with ME, the condition ME, myalgic encephalitis, because those conditions match tyrosine deficiency, and they also match mold exposure. So just be aware of that. Now, food sources. Let's talk about how do we eat tyrosine. There's a lot of different food sources. You can see here in the meat family, beef, lamb, and pork, all good options. These are some of the highest levels. We got good levels in poultry, chicken, turkey, and duck. as well. Seafood, some options: salmon, halibut, sardines, lobster, crab. Dairy, as I mentioned earlier, tyrosine was originally isolated from cheese. Organ meat, very rich, especially beef heart and beef liver. And then we have some nuts, seeds, and legumes that are rich in tyrosine as well, for those of you who are trying to eat less meat or possibly on a plant-based diet. So peanut, pumpkin, and sesame seeds, black beans, kidney beans, garbanzo beans, tofu, almonds, and pistachios, all good sources of tyrosine. As I mentioned earlier, make sure you're buying organic, because if you're buying stuff that's been sprayed with glyphosate, you run the risk of any plant-based food not containing adequate quantities of tyrosine. All right, so beyond food, let's talk about supplementation, how to use tyrosine supplements. So the first thing is, when you're taking tyrosine, you're looking for L-tyrosine. And so you want to see that L in front of it. Dosing, what I'm giving you here is just kind of, if you're at home alone, going this alone, these are reasonable amounts that you can take without getting into too much trouble. But 500 to 200 milligrams a day. I said 200, I meant 2,000, sorry. 500 to 2,000 milligrams a day for dosing. Now again, clinical studies have used doses ranging from 100 to 150 milligrams per kilogram, and some even higher. So I think we've seen studies with tyrosine up to 30 grams a day with no major untoward side effects, although we will talk about some of the side effects, because this is one of the amino acids that can give side effects, and you want to be aware of what they are. As far as taking them and the timing, anytime you're taking an amino acid supplement, this includes tyrosine, ideally you want to take it 30 minutes before a meal. And that's the main reasoning behind that is, if that meal contains protein, so if you're eating a heavy protein meal, you want to get that tyrosine in and absorbed before you put that rest of that protein in, because a lot of these amino acids from the meat will compete with binding sites of absorption with the tyrosine. So in an ideal world, you want to take it 30 minutes away from before the meal. Now, if the meal is just going to be like a light snack, like a banana, or some piece of fruit or something like that, you can take it with it. It's perfectly fine. Again, the reasoning behind this recommendation is that if you're eating high protein at your meal, you might minimize some of the tyrosine absorption. You also want to take it before 4 p.m. And one of the reasons why is tyrosine, because it stimulates dopamine and epinephrine and norepinephrine, for some people, it gives them kind of a jittery alertness. And so you don't want to take that. You don't want to take that at night, because it can keep you up. It can keep you from falling asleep effectively. Okay, word of caution down here: do not take tyrosine if you're on prescription MAO inhibitors, MAO, monoamine oxidase inhibitors. These are usually medications that treat depression. So if you're on a MAO inhibitor, this isn't the supplement for you unless you're getting off that MAO inhibitor and you're looking for some natural options instead, but that's something you'd want to talk to your doctor about. The other thing, if you have Graves' disease, which is hyperthyroid, now we know that tyrosine can be beneficial for people with low thyroid if they're low tyrosine, but people with hyperthyroid, which is the opposite problem, you want to be very cautious with taking high doses of tyrosine, and I don't really recommend doing that unless you're under medical supervision. So if you've got a good doctor that understands nutrition and you want to consider tyrosine, don't do it without medical supervision. I would recommend you get your lab tests done and really kind of monitor it. So again, those are ways to take it. Now, let's talk about some of the side effects of tyrosine supplementation. One can be nausea or stomach pain. Not uncommon to see that at super higher doses. Now, not so much, these side effects are going to be more in the range of like 5 grams plus per day, at least in my experience. I'm going to give you my experience. That's not to say these symptoms couldn't happen at lower doses. They certainly could. Some people are more sensitive than others, but just be aware and be alert if you're taking it. But nausea, diarrhea, headaches, because tyrosine can break down into a sub acid that tryptamine that can trigger headaches. We see some people have the opposite effect where they get fatigued taking it, and then, as I mentioned earlier, jitteriness, anxiety, or mood swings are also a potential possibility. And then increased heart rate or palpitations. Again, what are we making with tyrosine? What are we potentially increasing with tyrosine? Stress, hormones, adrenaline. If you've ever had an adrenaline shot, in a hospital type situation, you experienced increased heart rate and probably a little bit of anxiety waking up with all that adrenaline in you. They sometimes inject people to save their lives with adrenaline because it just wakes everything up and alerts everything, including the heart. So tyrosine is a precursor to that. So again, if you're super sensitive, you might develop those heart rate increases or palpitations. So just be aware, so that if you do have these things, if you add tyrosine to your repertoire of supplementation, just be on the lookout. It's not super common. It's not something we see a lot of people experience, but it is something that can happen, so be aware. Lab testing. There's a couple ways you can look at tyrosine. One is in the plasma, so plasma amino acid testing. The range for tyrosine is generally 30 to 120 micromoles per liter. Generally speaking, if it's over 200, that's what's considered high. This is when, if you push your level up that high, that's when you're going to run into some of those symptoms that I mentioned. Now, the thing about, let me back up on the supplementation. The thing about tyrosine is that generally, when you take a big dose like that, it lasts for about 8 hours. And then your levels return to baseline. So, if you do have side effects, if you do a heavy dose of this stuff, about 8 hours, this stuff's going to clear out of you, and you should return back to feeling okay. So again, plasma, 30 to 120 micromoles per liter. Intracellular testing, this is my favorite way to go about it, is intracellular, because plasma is affected from the day-to-day, right? Just like any other serum blood test, your last meal can affect it. If you ate a plate of liver last night and you go to your doctor, you might have, a much higher level based on that focused bolus of food consumption. But chronically, if you don't eat that stuff all the time, you may actually have overall low levels. So whereas this is measuring, the last 24 hours, your diet affects that. This does not. This is an average of 6 months. So this kind of gives you a 6-month window of your nutritional status. So in my opinion, it's just a more accurate way to look at it and to assess whether or not you want to look at supplementation. Now, on top of that, I'm going to show you this diagram again. What we were talking about earlier is, you're taking tyrosine. Generally, why are we taking it? If we're taking it as a supplement, we're after the benefits. We're after the effects, right? And what are the effects? The effects are not tyrosine directly. The effects are what tyrosine does. So what are the downstream effects of tyrosine? Well, one is dopamine. So we're after that impact and effect, that dopamine improvement, especially if we're low dopamine. So we're after that improvement in dopamine. In order to get from tyrosine to dopamine, you also need B3, iron, folate, vitamin D, omega-3, and vitamin B6. And so I'm very biased here because I run so much nutritional testing in my patient base. But vitamin D and omega-3 are two of the top 5 deficiencies I see in people. And so if you're pumping high doses of tyrosine, but you don't have the adequate quantities of these nutrients to do that conversion, it's not going to work very well for you. And I think that's one of the reasons why a lot of the human studies on tyrosine are, we'll just say, some of them show good benefit and some of them don't show great benefit. And my biggest question mark to those doctors and researchers that did perform that research is, were they measuring these things? Were they looking at tyrosine's cofactors as it is involved in the production of these other chemicals? Because if they weren't, it makes sense that if a person's deficient in some of these things, that tyrosine's not going to have the benefit or the effect that they're after. So going back to testing, if we're testing tyrosine to determine whether or not we should take it, we should also really be testing these other nutrients that help tyrosine get to dopamine and get to norepinephrine and get to epinephrine, because it's these three here that are giving us the impact and the effect that we're after by using the supplement. So again, B6, iron, vitamin C, and copper over here, SAMe and magnesium. So important, in my opinion, to measure these other things. If you're not, you might try tyrosine, it might not work as well as you want to because you have deficiencies of other things. Now there's also, as we said before, tyrosine also is important for your thyroid, particularly your T4 and your T3 hormone production. And so just this is more anecdote from what I've seen clinically. There's not a lot of research on this, but I've seen this quite a bit in practice. When you're giving tyrosine and somebody's on thyroid medication, so if that person's on a medication, it's very important that they know that if tyrosine's benefiting the production of their thyroid hormone, in other words, if they have a tyrosine deficiency or phenylalanine deficiency and we're getting more T4 and more T3 production as a result of supplementing, then the medication can become too strong. And this is one of the reasons why I think some people have, when they're taking tyrosine as a supplement, why they have the heart palpitations, why they have the jitteriness, because this effect is happening as well. And if they're on medication, medication becomes too strong. Sometimes they get cold feet and they want to stop the tyrosine, and that's not to say they shouldn't, but if we can enhance the body's natural ability to make its own hormone without needing the medicine, isn't that an ideal outcome or an ideal situation when we can use a food-based nutrient to enhance body function? So keep that in mind. I had a patient one time, this was years ago. She started, in her case it was iodine, not tyrosine, but she started iodine. And remember what we said earlier, thyroid hormone, the T is tyrosine, and then the 4 is iodine. And so either one of these nutrients could cause heart palpitations, increased anxiety or jitteriness if you're taking medicine, because when you take these supplements, iodine and tyrosine, it gives your body the substrates necessary to make its own thyroid hormone. And if it works well, the dosing of your medicine might be too high, and that can happen rather quickly. And the quickest I've ever seen it happen, a young woman, within 3 days, I started her on it on a Friday. She called me on a Sunday, and she was having severe heart palpitations as a result. So in her case, it turned out to be that her medicine was too strong and her nutrient supplementation was just that effective. So be aware of it. It doesn't happen to everybody. It doesn't always happen in 3 days. Sometimes it takes several months. But point being, this micronutrient, amino acid, it is a requirement for the production of your thyroid hormone. So you really want to keep that in mind if you have hypothyroid and you're on a medication. Okay, so and then likewise too, as I was saying about lab testing, same thing goes here for lab testing. If we have, if we're looking at cofactors, right, for L-DOPA, dopamine, norepinephrine, epinephrine, we also would want to look at, ideally, the cofactors involved in thyroid hormone production. And what are those? What are the nutrients that revolve, not just tyrosine? It's not just tyrosine that makes thyroid hormone. There's other proteins involved in it too, but it's tyrosine, it's iodine, it's vitamin B2, it's vitamin C, it's zinc, it's magnesium, it's iron, it's omega-3. You notice there's a lot of overlap here. It's also vitamin A and vitamin D. So these micronutrients all play a role in regulating your body's ability to make thyroid hormone. And so if you're taking tyrosine and you're not really finding that it's all that helpful for you, it's very possible that the reason it's not all that helpful for you is because you're lacking other key cofactors that play a role in helping that tyrosine get to T4 and T3 and allow that T4 and T3 to work. So, you know, we talk about tyrosine, we're talking about testing for specifically tyrosine, but ideally in the right world, nutrition doesn't work in a bubble. If you just measure one nutrient, it's not super comprehensive because there's overlap and there's relationship amongst nutrients that play together. And so it's ideal if you're embarking on a nutritional journey with your doctor that you don't just measure the one nutrient, that you measure the battery of at least the essentials. And so what would those be? Those would be your major amino acids. That would also be your vitamins, all of your vitamins, and your minerals, and some of your other metabolites that play a role in these, like inositol and choline and others that aren't technically, classically considered vitamins. So INA testing, you know, if you do a good one, like if you do the one on Gluten-Free Society, we measure 55 different things, including all those things I just talked about. So if you really want to know, get tested, don't guess, so that you're targeting what you need and you don't end up with either a lackluster experience using tyrosine or the side effects because you're missing a piece. So anyway, hope this was helpful for you. Do me a favor, hit that like button below. If you're not already, hit that subscribe. And if you think this could help somebody else, remember our mission is to save 100 million lives. So share this video with somebody who might need it. Thanks so much, and we'll see you Thursday for live Q&A. Thanks for tuning in to the Dr. Osborne Zone. Don't forget to share, like, and subscribe for more content like this, and make sure you come back next Tuesday at 6 p.m. Central Standard Time and Thursday at noon 30 for more episodes.